Hi, everyone. Welcome to today's live Tech Talk, the intersection of data center AI and sustainability. This event was organized by the hardworking folks at the Virtualization and Cloud Review, and it's sponsored by CyrusOne, delivering proven platform solutions and experience that enables seamless connectivity to customers and partners across the globe. I'm John K. Waters, Editor-in-Chief of the Converse 360 Group of 1105 Media, and I'm joined today by Jim Roche, Senior Vice President of Engineering at CyrusOne, and Kyle Myers, CyrusOne's Vice President of Environmental Health, Safety, and Sustainability. Welcome, gentlemen.
Thanks for having us.
Here.
Glad to have you. I want to tell the folks a little bit about you guys. During his quarter century in the industry, Jim has amassed extensive experience with data center design and build, and he has applied that experience to the management of global data center operations. His expertise extends to capacity management of power, cooling, and infrastructure cabling. He currently leads engineering development at CyrusOne, where he oversees power projections, floor planning, and connectivity assessments. Recognized as a Sustainability Hero of the Year by the Business Intelligence Group, and named to the Environment Plus Energy Leader 50 honoree list, Kyle is a seasoned professional with multiple certifications and active involvement in EHS organizations and leadership councils. He currently leads the Sustainability Working Group at CyrusOne, which drives his company's industry-leading sustainability efforts. We've got some heavy hitters here today. You guys are in for an awesome session. I'm really looking forward to this conversation, but I need to do just a little bit of housekeeping. The Tech Talk is being recorded for later access. Keep an eye out for an email with a link to that recording. It'll be coming your way in the next few days. Our sponsor has provided some extra resources you won't want to miss. They're available now on your console. And at the end of the conversation, we'll have a 5 to 10 minute Q&A. Please type your questions into the Q&A box at any time. We'll do our very best to get to all of them. Now I'm going to take just one more minute to sort of set the stage for what we'll be talking about today. As everyone knows, the widespread adoption of cloud computing combined with the recent warp speed growth of AI has led to unprecedented energy consumption in the data center. The power required to run AI workloads in particular is prompting organizations to focus on data center energy efficiency with a new urgency. And data centers are, in fact, continuously evolving to meet these new energy demands. But navigating environmental sustainability as it relates to green energy, energy-efficient hardware, and water conservation can be extremely challenging. The data centers of tomorrow, our speakers have said, start at the intersection of AI and sustainability today, with data centers designs that embrace the needs of AI and incorporate the capabilities of that technology for the must-haves of sustainability for tomorrow. Okay, let's dig in. Let's start. I want to begin the conversation. Maybe to start with Kyle, talk about the environmental impact of data centers. In what ways do data centers offset things like carbon emissions, and why has sustainability become a top-of-mind issue?
Hey, John, thanks for the question. As you kind of led, AI is really making a lot of headlines, but let me just start with anytime you're doing any kind of real estate development, there's a potential to have both a negative and a positive impact to sustainability. So we think about sustainability in 4 buckets. You kind of brought up the climate piece, both how we impact the climate and how the climate impacts us. We also think about this holistically in terms of water, biodiversity, as well as circularity. The other component I would say that the way that we're thinking about it at CyrusOne is also not just do less bad, but how do we do more good? So an example of that is in any high water stress region, so areas where water may not be plentifully available, we not only offset our use, but we go 20% beyond that to do more good, return more water to that watershed than what we might consume. Also an example of an offset.
Fascinating. Maybe a quick question for Jim here. From a business standpoint, well, maybe not a quick question, how do sustainability practices and designing for AI within data centers affect operational costs and long-term profitability?
You know, it's funny people talk about these high density deployments. I think if you look at it, when we can take this and design these buildings, these data centers, using less land, less concrete, less steel, kind of pack more into a smaller footprint. We're starting to check a lot of boxes, and that's from a carbon offset standpoint, an efficiency standpoint on the equipment that we're using and the amount of space that we're using it in. Hopefully, not using as much real estate and land when something like that happens. So anytime we can do that and maximize the components that go in a data center and maximize the efficiency throughout that portfolio, if you will, it increases the likelihood of profitability in the world, and that obviously is key. But we're, from an engineering standpoint, we're always trying to push it a little bit better, a little bit more efficient. And if you look at the history of data centers, you can see an evolution of where we were doing a one-for-one component failure. So when one component fails, it fails to a secondary component, and that was the way things were designed in a resilient world for a long period of time. And what we're seeing now is we're able to stretch these components and have one failure fall over, let's call it 7 components, fail over to one component, have the ability to fail over. So we're able to not install as much equipment, give the reliability to the application or the customer, and we're able to do it in a much more clean, efficient way. So I think as we see this evolution, if you look at a trajectory of data centers, it was, kind of slow even a decade ago. And then you started seeing this uptick and kind of a change of mindset that people had with resiliency and obviously profitability too. But as you saw this thing go, over the last 2 years, you've seen this major spike. And so when we look at that, people are becoming much better, much more efficient in the operation side of things too, managing these portfolios and facilities. The equipment's getting better. And I think you're going to see continued changes throughout the industry that's going to continue to increase.
It's fascinating. So what do you guys see as the sort of the greatest obstacles hindering, I guess I could say, the widespread adoption of AI and sustainability practices in data centers?
Yeah, I mean, I'll kick it off, and I'm sure Jim will have some thoughts to add here too. So generically, the availability of stuff that kind of started with COVID has hampered sort of lots of different things. Everything from renewable power, it's driven costs up. Power period has slowed sort of the adoption of a lot of stuff, like zoning limitations, zoning changes, and then sort of at the core, a lot of that is regulatory hurdles. So think about power availability, for example, or renewable power availability. There's been a lot of articles out. Forbes, USA Today, it seems like pretty much every day about concerns about power shortages. And a lot of the articles that I've read, at least, have pointed to the onset of AI is contributing to that. And a lot of folks are concerned about bringing more generation of power on site. But there's an argument to be made that it's not so much a generation issue as much as it is a transmission and distribution issue. And so West Texas is a great example of a place that's really good for solar arrays and wind power. So there's actually a lot of renewable energy attributes on in West Texas, but getting that power to where it's being consumed is the challenge. And there's a lot of regulatory hurdles there. So just in terms of like what's slowing maybe some things we'd like to do in the realm of sustainability, those are some big factors.
Fascinating. Jim, did you want to comment?
Yeah, I think you're going to hear a reoccurring theme, not only here, but throughout the data center industry, and Kyle spoke to it, and it's power. At some point, electricity, we all want to be in the world of clean energy. It's just with the the amount of power that is required, not only by data centers, but you hear all the time people talking about electric cars and charging electric cars that comes from power plants. So, when you look at these things, the answer isn't it isn't right around the corner. This isn't a solution that's readily available tomorrow. We have to plan a little bit better for the future. But the reoccurring theme you will hear is power availability. We're at a rate that they're talking about 4x, 4x what we currently have is the requirement for power in the next 20 years, which is a major obstacle when you look at these things. So power, and the second part of that is the cooling of data centers, somewhat related to the power of what is in a data center. But when you talk about AI or any high density deployments, it's great. I could put all the power I want into there, but I still have to cool these systems and keep them operational. And so one of the bigger obstacles that we're seeing now is the cooling aspect of data centers.
This is fascinating. I'm learning a lot talking to you guys, and I was just wondering about education within the industry. That's why I have this question. Within the industry, what education and awareness is necessary to maximize data center design and builds? Either one can weigh in. Maybe Kyle?
Yeah, sure. Happy to start here. So I think there's a lot we can do within the industry. So I think you're right. And we are part of like trade associations like Data Center Coalition, and others in different markets. But I truly think that the education really has to be outside the industry. So that's everything from a recruiting perspective, right? We're a high growth industry, so generate lots of actually pretty good paying jobs. And so it's everything from career prospects, sort of let folks know that data centers are an industry, and we need engineers, we need all sorts of different trades to contribute to our growth. So channeling interested students into a data center career is important to us. And then I think educating policymakers, right? So as we're looking at further expansion in key markets, or maybe looking at new markets, helping to educate people on the benefits that data centers bring to the community. So things such as tax revenue, right? So data center deployments, more so than most other commercial real estate, tend to be capital intensive in terms of there's lots of equipment that's very costly, and all that becomes taxable revenue for the communities in which we operate. We're also really light in terms of resource consumption. So police protection, fire departments, all that sort of thing. We don't consume a lot of those resources. So I think it's really important that we try to get out ahead of this and make sure that folks that where we're operating in their communities have a good understanding of what our contributions are.
Yeah, it's funny when you ask people what data centers are, although now people are starting to understand a little bit more what a data center actually is. Just a few years ago, it was, what do you guys do? Well, we build data centers. Well, what's a data center? Everybody knows what they hold in their hand and how they get to pictures and videos and stuff like that. But understanding that all comes from a data center in some way, shape, or form. And from the education and awareness, I think that, I look at inward at this one, because from a engineering and design standpoint, we have to really work closely with our customers. There's differences now in the world of data centers and sustainability playing a major role, and what we want to deploy and how we want to maximize what we're building and what we're doing. And I think the education and awareness part of this, looking inward, is us working much more closely with these customers. Not that we didn't in the past, but there is such a focus on it, as there should be, that it takes all of us to work together in this world of sustainability and data centers. So I think looking inward, the education, as much as it is on the outside of the data center industry, the inside of the data center industry has to look at it as well.
It's fascinating. To state the obvious, AI and machine learning is having a game-changing influence on, well, probably everything, but certainly a wide range of industries. In what ways are AI requirements shaping the architectural design of future sustainable data centers?
Yeah, so it's actually pretty interesting, right? So one of the big limitations we've had in terms of limits on sustainability is siting. So where we can put a data center, right? So we've typically been limited by the deployments by our customers that tend to be in high population centers, right? And so you wind up having, from a ecology perspective or a sustainability perspective, a concentration of resources. We do it more efficiently than if you try to do it on your own, but they are concentrated in one geography. So if that geography happens to have, for example, intensive grid coal power, that's not a fantastic side effect of that siting decision. But with the deployment of AI, what we're seeing is a lot more flexibility. So AI sort of has two primary components to it. The training component does not necessarily have to be in a population center. So you can go to where, for example, the renewable energy is cost effective and available. That's one component where you're going to have less impact on biodiversity, where recycling is more readily available, where there's less water consumption, et cetera. And then I would also say that another sort of benefit is actually being able to use the technology itself as we look to either better predict resource availability or potential interruption to data centers based on location, or even simple things. An example being that if you're using, like we use learning management system, right? So there's AI tools just to do simple things like make training easier to develop, which allows you to spend resources on other sort of more productive uses of time.
Fascinating. Jim?
Yeah, and I think, from an architectural standpoint, again, just going back to just building smaller facilities that take as much power. Back in the day, Kyle and I have talked about this. When we look at just concrete, you're using a quarter of the concrete that you used to use for the same amount of power that you were putting into a data center. So, that's helping drive the sustainability a bit. That design that we're able to cram more into a smaller footprint, it does help us a lot, checks a lot of boxes. But, when we look at other things, we do use the AI world for predictive things too. So different designs that we can run more analytics on and see what something may or may not look like, based on, we could think up the greatest designs in the world, but we actually have tools now that are able to prove things out and prove them out relatively quick of a way we want to go with design. So as much as we're trying to solve for today's problems in the world of data centers and AI being one of them, we have to keep in mind what tomorrow might bring. And so we don't want to just take this and look at it as a today problem. If we're seeing anything in recent months, it's that this is somewhat of a rocket ship that we're trying to solve for. And so keeping the flexibility, using things like the information that Kyle can provide us and the architectural side of CyrusOne, being able to design things around all of this has really been key as of late.
Well, Jim, what would you say are the primary challenges encountered in integrating AI technologies into the data center?
Well, it goes back to that central theme, right? It's the biggest challenge that we have is power. Getting power to a site. Back in the day, if you think about it, when we built data centers and designed them, if you were to go to a utility, and that's, ComEd, Dominion, Duke Energy, Encore, any one of the utilities, and you'd be building a data center in a place and you'd ask for 10 MVA of power. And that wouldn't be a big deal. And you knew even at say 10 megawatts worth of power going into one building, that would grow slowly over the course of, say, 3 to 5 years. You'd be looking to absorb that. Well, it changes drastically in the world that we're looking at now. We're not asking utilities for 10 megawatts. We're asking utilities for a minimum 100 megawatts and usually more than 300 megawatts to be able to put a flag in the ground of where we want to build. So the challenge always, at least for the foreseeable future, is going to be power and generation. To Kyle's point, the generation in a lot of places is there. It's getting power to where one may or may not need it. And that's changing the landscape of where data centers are going as well. So challenges where we used to look at things and at a very high level, think of it as the major NFL football cities. You used to design around those. They'd be somewhere in where connectivity was plentiful, where you could get power. And like I said, when power was smaller, the needs were smaller, it was much easier to do. Well, now the challenges of getting power in those areas have become great. And now the data center world is evolving now they're pushing it out to different places. And so, pushing it out to where there is land is one thing. Now trying to get power out to where that land is another. And so the central theme I keep going back to is power.
Okay. So looking ahead, I always have to ask the future question. What are the emerging trends that you guys see? We're talking about the intersection of AI and sustainability. What do you believe will have the most significant impact on data centers? Maybe start with Kyle.
Yeah, so looking beyond power, because we've talked a lot about that, but it is very much a sort of front and center for us. I think the policy environment is going to drive a lot of how quickly we're able to sort of accelerate if you want to call it the AI revolution. So one of the biggest challenges with getting power stood up is, and I'll go back to the transmission and distribution thing, right? So like the power lines you see running across highways and neighborhoods, getting power lines built, especially like new high technology ones that can take a lot of high power with less loss, requires you typically to go across a whole bunch of people's private property and sometimes also impact or go up against green spaces. And so the regulatory hurdles, even if it's a desert type of an environment, are significant, and it really slows the ability for any power company or anyone else looking to get the power to the right area to do that in a quick manner. So it's such a big consideration. It's not just the data center industry; it's anyone who's in infrastructure that requires energy generation in the form of electricity. Like our CEO went to a CEO event hosted by Jamie Dimon to talk about how to overcome this and how some of the biggest companies in the world can help influence policymakers in such a way that allows us to more quickly bring that generation online. So I heard a stat recently that there's more renewable power generation waiting to be approved than the totality of renewable power that's online in the US. So it's not the ability to, or the investment, or people willing to add more renewables to the grid. It's running into policy barriers for the most part. So the more that I think data centers are recognized as being part of critical infrastructure, the same as water plants and power plants and other assets, my hope is that we find better ways to be able to solve for some of those problems.
Absolutely fascinating.
Yeah, I think thinking of two things from an emerging trends aspect. I'll start with a negative one, or maybe it's not negative. In Kyle's world, it's extremely positive. But when you think about the generators that sit behind data centers in today's world, at some point you're not going to have the ability to put hundreds of generators on a site, and I mean, we're literally talking about that. If you look through even our data center portfolio in Texas, how many generators are sitting there? That the reality is they don't get used very often at all. But by requirements and mindsets of most people, it is still something that they want as a form of backup to make sure that their power is going to be consistent and always on at a data center. And so we're getting to a world where they're just not going to approve them. anymore, or the ability to run them is going to be limited so much that it's going to be one of those, do we even put them in if they do allow them? So, that's one of the trends that I see is this move away from on-site generators as a means of backup for data centers. And kind of tying into that on the flip side of it, the most positive thing that I think, not only in data centers, but in power generation in general, anybody who's heard me talk is nuclear energy. I don't think you can sit anywhere and say that you are trying to lower carbon and create a carbon neutral, carbon free environment when it comes to power and not embrace nuclear. I think nuclear energy has gotten a very bad rap over most of its lifetime, probably more so since the 70s. It didn't help having a movie Chernobyl come out and reignite everybody. But the truth of nuclear is it's far safer than every other form of power that we're producing. And it is trending in such a way that the safety factor of nuclear just keeps getting better. You're going to see some trends in the very near future where nuclear becomes a bigger part. If you look at the power generation across the globe right now, it's just under 20%. So call it 20% of this world is powered by nuclear. But that 20% accounts for more than 50% of all carbon-free production. So it's if you truly believe, like we've lost some pragmatic thought over the years, and having real true dialogue, because either louder voices have prevailed, or maybe people just approached it with a little bit more vim and vigor on the anti-nuclear side. But I think we really need to sit at a table and say, if you want to achieve these things in this world, and power is going to be one of them, and the people who think you're going to charge all of the battery operated cars that they want everyone to drive, then the trend that needs to really ramp up is nuclear.
Okay, finally, what advice? How can I put this? Based on your experience, we'll put it that way. What advice would you give organizations looking to navigate the path toward leveraging AI and sustainability in their data centers? Maybe start with Kyle.
Yeah, but I'm just gonna echo what Jim had said earlier. So Jim mentioned sort of two things that were important for us, and I think it's worth taking the time to think through this for your own organization. So one of which is thinking holistically about this, in terms of, at least within the sustainability world, there's a lot of folks that get to laser focus on climate, right? And or their impact or the impact of climate on themselves. And that's certainly important, but you shouldn't be too myopic, just focused on that one aspect of sustainability, which leads to the second thing that I heard Jim say is future proofing, right? So when you talk about assets that are online for 20, 30, 40 years, up to indefinite, right? If you're talking about the building structure, yes, key equipment will have to be swapped out, but the building keeps operating. You really have to think longer term. So the challenge with AI specifically, but it's been, I guess, increasing frequency of changing trends in this industry driven by technology. So it's becoming, from my point of view, harder to predict further into the future what the need set is going to be, because the, I guess, intersection of not just AI and sustainability, but different types of advanced technology like large language models and breakthroughs in medicine, for example, or material science, cause huge leap forward in terms of our ability to create whatever better microprocessors. So I think those are two of the things that you really have to view through the lens of what's important to your industry and what's your impact going to be, and spend the time or make the investment to do due diligence to understand them like where that fits within your environment.
Yeah, I think that's spot on with that. I mean, it's conversation, really. When we're looking at these things and when things are changing at the rate that they're changing, and they're changing in drastic steps, not that this isn't just little trickles. This is big paths forward. And I think when we look at conversation and working as partners in this thing completely, I think that's where, not only the CyrusOne working with their own customers, but CyrusOne working with other colo providers and sharing information and talking about, what trends we've seen work and just getting to that world, I think is going to be, I think that's going to create the best path forward when we're looking to leverage all of these things and create a better mousetrap, if you will.
Well, that's all my questions, but we have got a bunch of questions from our attendees. I want to remind everyone that you can type your questions into the Q&A box at any time. We'll do our best to get to all of them. Let's see. Let's start with this one from Vic, who's wondering, we have referred to PUE since the inception of outsourcing data centers, but how important are CUE and WUE becoming as serious considerations for who companies outsource their data centers to? Just to clarify, PUE is power usage effectiveness. This is not for you, but for attendees. Carbon usage effectiveness is CUE, and WE is water usage effectiveness. Kind of a long question. Whoever wants to take it.
So I'll say this about the PUE. Jim may want to have more to say about that. Like PUE, how efficient the use of house power is to support IT load basically is sort of a very common standard. It's tied to everything from green financing to how we're benchmark and competitive. But there, in terms of how efficiently data centers operate. But I think most people within the industry think that's not probably an ideal metric to measure that, as the data center is as efficient as the equipment is in it. And Jim can probably talk a lot about that from an engineering perspective. So let me touch on the other two just for a second, and then Jim can jump in on whatever he likes. So I do think it's important, as we talked about, to be holistic about this, right? So however, whatever your PUE number winds up being, it's not all about just energy efficiency, whether it's that metric or another one. So there's the carbon usage effectiveness, which basically gets lower as you have greener inputs into your power, right? So it really highlights that the folks are investing in renewable or carbon-free energy sources. So I do think CUE is important. And the other nice thing about it is it takes growth into consideration, right? So if you're a high growth industry like us, it's hard to keep the absolute numbers from growing. But on a rate basis, it really measures how well we're progressing. So we do publish that. You can look it up if you like. And then WUE, oftentimes there's potential trade-offs in terms of you can evaporate a lot of water to lower your energy usage. And that's why we publish that number as well. So you can sort of contrast and say, okay, well, are we getting super efficient energy at the cost of water or vice versa? So I think all three are ultimately important.
Yeah. And I think when you start talking about PUE, the concept that everybody has to start getting more familiar with is that we need to run our data centers at just warmer. At some point, Kyle did say this. It can only get as good as the components you have in there, and until we get to a world where we're raising water temperatures, thus raising air temperatures, and playing around with delta T's a little bit more within the data center, we're just going to be stuck in a world of the 1.2s on the PUE side of the house. So I think that's going to take some people getting comfortable with it. And I don't take it lightly, because I understand that the people who you talk to and have to deal with the PUE side of the house are the ones that, if I get them to approve it, they are the ones that will lose their job when systems start failing. So it has to be a more collaborative effort throughout your organizational chain.
Okay, we've got a question here from Lynn, who's a frequent flyer. Hi, Lynn. Let's see here. Oh, I lost it. It's disappeared. Let's do this one from Grace, who's asking, are terabytes a free energy source? Are terabytes a free energy source for AI power stations? I'm not sure what that means. Let's go to this one from Colm. Grace, if you could clarify that question, I'll ask it again. Colm is wondering, given the cooling requirements for AI workloads, high density might be next to standard 10 kW workloads. Are you changing your data center design to cater for mixed environments?
Yeah, I'll take that one. So the design is really the same within our data center in that, we would tap off of that off of the loop system. We use a closed loop system. So, we can tap off of that to do liquid to chip, liquid to door, liquid in-row cooling, immersion technology, or run traditional craze or fan wall units. So it's not really changing the components and what we're doing from a large standpoint. If we look at the standard equipment, if you will, the chillers and the craze and whatnot, we're not seeing it so much there. What we are starting to see, we are designing mixed use environments where day one customer comes in with a 10 kW per rack installation, but knows that within the next couple of years, or when they actually have availability of the equipment that comes in, they want to be able to roll it in and connect it direct to do some sort of DLC or liquid to chip or rear door, some sort of high-end cooling. And so we are designing our data centers as much as the customer wants to take on day one. It can always pivot to that in our design day two. It's just that how intrusive do you want to be? And intrusive in our world is just adding the pipe underneath. So moving some stuff around and having to work in a live environment. If we can do that day one, there's a small uptick in cost to do that, but it's 20 cents on the dollar to do it while we're building out the data center from the beginning. And that takes you from a 10 kW design as high as 300. I know this sounds crazy, as high as 300 kW and above at a per rack basis.
Fascinating. Okay, we've got one here from Paul who's wondering, is CyrusOne green power certified? And can those benchmarks be maintained even under a heavy AI data workload?
Yes. So all of our renewable or carbon-free energy is certified in that we get either attestation or we get the attribute from the provider. We go through third-party assurance, so all of this is reviewed by a third party to ensure it meets greenhouse gas accounting standards. So that's all current best practice. In terms of maintaining that, I think you have to maintain to have legitimate claims at renewable power that you can pass assurance for. You have to maintain that credibility. But it is a challenge in some markets to procure adequate amounts of green power. And so for the US grid, just as an example, there are certain markets that are monopolistic. So there's like one energy provider and you're sort of stuck with whatever they can and cannot provide. And then there's other markets like Texas, the opposite spectrum, particularly North Texas, where you have more options. So what we've seen in general is monopolistic markets are more of a challenge as we don't have a lot of say. And so it is difficult to get enough power, to enough green power as we would like versus other markets. So I think everyone in the data center industry and probably all industries that are committed to consuming clean power would like to see more availability in every market they operate in.
Okay, here's one from Lee who's wondering, what type of AI technology are you using for your AI analytics that allows you to confirm the efficiencies that you are stating in developing these DC?
Ooh, that's a good one. So I don't want to speak for the operations guys who use that more than I do. The technology that we're using on the engineering side, at least from the electrical mechanical, has been engineering that have been products that have been out there for quite some time, in the form of CFDs and airflow dynamics. So that part really, it isn't an AI driven, other than the fact that it does speed up the process, and have us look at multiple data centers across each other. But other than that, there isn't any that I can think of that we're doing in the design phases, where AI has really driven us in one way or another, other than building a data center to meet the needs of an AI product, but not in the design itself.
Okay, here's one from Tori. Oh, sorry, go ahead.
I was saying, I hope that makes sense. I know that was a long way to go.
I think it did. Okay, here's one from Tori. I hope I've lost it now. Where did it go? Here it is. When thinking about PUE, CUE, and WUE, which should be the top priority as it relates to data center location?
As it relates to location, I would say I guess two ways to think about that.
Well, you can eliminate one, Kyle.
Which one?
So the WUE for us is not.
Oh, yes.
It's not a big thing. So we could take that off, since we're a closed loop system and we don't use evaporation as in a form of cooling for our data centers. You can take that one off. So in general, that now you're down to two. Kyle can answer the one of two.
Yeah, so I would say this: it's driven. The answer to the question is driven by two things. So, power usage effectiveness is easier to make look good in cooler climates, right? Because just because there's less, it's easier to get rid of the heat. And so, if you're really focused on driving down PUE, that may be a consideration. You go to, I don't know, the Nordics or somewhere where there's plenty of cool air, which naturally will lead to more efficiency. The CUE, which it integrates in the grid carbon aspect, the answer to that is locate close to low carbon sources to solve for those. So it really depends on which problem you're trying to solve for as a data center.
Okay, this one's from Calm. It's a nuts and bolts question. What's the optimal or maximum rack density you can cool with AIR alone? 30 kW, 40 kW?
Yeah. No, that's a good question. So that's an interesting question, because I don't want to be, sound like I'm talking around it. It really depends on how many of those racks we're talking about. So we've been able to push 36 kW a rack pushing air. However, you're very limited on the amount of cabinets that you can put in a given area. If I was looking at a data center as a whole, what we typically do is we will fire a CFD off against it, computational fluid dynamics, just to see how the airflow operates and make sure that we can maintain an SLA that we guarantee within our spec. And when we start getting to that, I always used to say that 16 kW a rack when we were pushing air was a number that I started, I felt really good about. You get up to 20, you really have to start watching. You start looking at how much CFM per kW you're pushing, if you're using a raised floor, what kind of pressure you're pushing underneath that floor. And what the densities are. So when you spread that across the whole data hall, it becomes a what if number. I would say in the world that we're looking at now across, and let's just play it out as a 50,000 square foot data hall. If you put that into a rack count, you have no problem spreading load across there and getting to 20 kW a rack. It's where you start looking at things like how wide a of rows or how many cabinets in a row a customer has and what their delta T's are. That's one of the things that some of the customers want us to do all kinds of things, but then they have delta T's on their systems that just they're kind of, they want the best of both worlds, and it just doesn't work that way. So I think when we start looking and then take it one step further, this is what happens when an engineer starts babbling on. When you're talking about air, you could be talking in the form of rear door heat exchangers, which we can put on the backs of cabinets and run, 50, 60, 70 kW all day long on those cabinets. So in the form of air, when you're talking about it, there's a couple different ways to look at it. It's whether we're pushing air to an entire data hall or whether we're starting to take on air at a cabinet by cabinet level.
Okay, here's a long one from James. Let me see if I can get this right. It's a question about site selection and location of data centers near power generation. How are data center developers beginning to think like utilities, in quotes? Is there a natural alignment to drive more seamless collaboration and integration planning between energy and digital infrastructure sectors?
I can answer that 100%. Yeah, there is, and everybody I'm sure knows there's lots of conversations that are happening now with data centers and the utilities, like in a help me help you type scenario. I mean, like what Kyle had brought it up already. If generation is there and distribution or transmission is the problem, then tell us where to go. Like help us go to a place. We used to do this back in the day where we would just say, here's where we are, get us the power. And now we're going the other way where we're telling our land procurement people saying, go find out where the power is. And then we'll try to get the customer to those areas to make it easier because everybody needs this power in a very short order. So it is a lot of collaboration that we're doing with utilities far more than we used to.
Okay, you talked earlier about backup power. Cal is wondering, with the MW growing to 100 to 300 MW per data center, are you changing your architecture for backup power?
Yes. Yeah, we're doing, what I was mentioning earlier was in a world where we would like to get away from generation, knowing that in a 100 to 300 megawatt, I'll call it a campus, you really don't want that many 2.5 megawatt generators sitting around doing almost nothing for 99.999% of the time. And so we're working with customers diligently on what's acceptable now. The world has changed. So what's acceptable for having or the need of generators on site, and what does their tolerance look like? I think we'll get there. I think we'll get to a world where, maybe UPS still stays in the system and generator sits on network only or sits on some sort of critical part of their infrastructure and not across the entire infrastructure. So if I have a 50 megawatt building, maybe 10% or less is actually sitting on generator. I think that's the world that absolutely we'll get to, and we'll either get to that because regulations are such that they're not going to improve, diesel gens on a site, or we get to a world where everybody's okay with putting scrubbers on gens, be that gas or diesel, that the carbon side of it is super low. So I think as this thing keeps progressing, we'll get to a almost genless data center design.
Fascinating. Okay, we've got time for one more question here from John, who's wondering, are you doing higher voltage distribution in any of your data centers?
Absolutely. So all the way from the transmission side, if we took it all the way at the high side where we're getting it from the utility, we're going with transmission grade voltage coming into a building. And we're also virtually at, all of the bigger guys are already at the 415 type voltage solution. The next step would be the the guys getting into, 480 delta into their systems, or, running at 480 at the higher voltage. But we have seen a lot of it. The days of 12208 are, it's a smaller and smaller percentage of deals that we're signing. Where virtually everybody's is looking at the higher end of it, and either the 230 volt single phase. Most customers are good with bringing that on, and if we can get to a world where we're doing 480, 277, even better. The less times that we have to knock that voltage down in the form of transformers, the more efficient the whole system becomes.
Well, guys, that's all the time we have for this Tech Talk. I want to thank Jim Roche and Kyle Myers for an informative conversation, and many thanks to the folks at CyrusOne for making this conversation possible. This was absolutely fascinating. Thanks, guys.
Thank you.
Thanks for having us.